Hello and welcome to the How the Internet Works module of teaching best practices for online and hybrid courses. This module is meant to help you understand how the internet works from a very foundational and basic level. We're not going to get into protocols and packets and all those sorts of things, but what we are going to do is try and create an understanding of how traffic flows on the internet in order to help you visualize what happens when you log into Canvas or Microsoft Teams or upload a document or start a live session with someone. So to do that, we need to understand that the internet is not one big network. It's not like a master network out there. Even when we break it down to its very core, the internet is an interconnection of millions of smaller networks. Now, yes, there are what are referred to as internet backbone. It's still not one big network. The internet backbone has interconnections as well. But when we think about the internet and how it works, we have to remember that there are millions of networks that make up the internet that connect and pass data from one place to another. And all of these networks, all these millions of networks, have different rules for talking between one network to another network. So there's no one set of rules as far as what's allowed, how fast it's allowed, how much of it's allowed. It's all different. They do use a common protocol set. And when you think about rules, you often think of protocols. The protocols simply define how the data looks and feels when it comes from one place to another. It does not dictate how much data, how fast that data can move, or what kind of data it is that can move. That is dictated by the smaller networks. Almost all of these networks have their own subnetworks. So, for example, if you think of the internet backbone as the internet, and then you have millions of other networks that are connecting, say from Comcast or Verizon or Penteledata or Cox Communications, whomever your local connection might be, below them, there are also millions of other networks that interconnect through them. And then below them, there are often millions of other networks there. And even when you get down to the smallest level, there are often subnetworks within those networks. And those subnetworks are always controlled by the network above them. So when you connect at home to, say, Comcast or Cox Communications, Comcast or Cox Communications is giving you the rules of their road. And then they have to live by the rules of their uplink to the internet, just as you have to live by the rules they give you to live. Your home or school are one of the small networks that interconnect through a larger network, as I just mentioned. So you might connect through Comcast or Penteledata or Cox Communications. At my place of business, we connect through Penteledata, and Penteledata connects up pretty almost directly to the internet. They are a tier 1 provider, so they are considered to be as close to a direct connection to the internet as we can get. But we are governed by the rules that Penteledata gives us. So, for example, some of those rules are: here's how much data you can pass through at any time. Here's the type of data that you can pass through. And they also will from time to time say this type of data is okay and this type of data is not okay, depending on what's happening. So that gives you an idea of what is on the internet. Let's take it the next step, and we are going to illustrate for you what that really looks like. So I've got a little whiteboard here, and I've got the internet. So when we talk about the internet, we're going to go back to the idea that it's not one big network. However, to help illustrate the millions and millions of network, I'm going to do what everyone else does. I'm going to draw a fluffy cloud. Mine's a rainbow cloud because I think that shows all the different types of data that you can see on your internet, whether it's pictures, movies, sounds, Facebook, Instagram, Teams, Google Suite, whatever it is that you're working in, it's all in here. It's all in there. Then what we're going to do is we are going to branch off, and I'm going to say right here, and we're going to draw a box that says, this is Penn Teledata. And we're going to draw a box here that says Cox Communications. That's a really big box. I feel like they don't need that big of a box. Cox Communications here. And then we are going to come up here and say this is Verizon. My penmanship is terrible, so please excuse that. And then we will go over here and let's say some of you maybe use AT&T. Fine, cool, no problem. So for example, when we look at, I'll just say the big I, internet, which is the cloud of the networks that comes together. When we branch off, we want to say Penn Teledata has colleges and universities and schools, not dissimilar to the ones that I might work at or you might work at. And they have homes. Actually, I have jumped ahead of myself. So what Penn Teledata will do is then say, well, this is Allentown because I live in Pennsylvania. And then maybe this is Bethlehem. And then maybe this is Quakertown area. Okay, so now we have branched off Penn Teledata to different geographic regions. And then once we break down, let's say, we're going to say Allentown, and we're going to say Route 1 and Route 2. And then these routes represent sub-geographic locations. And then we can branch it down into different neighborhoods. Now, I do not know the names of the neighborhoods, but let's call this one Center City, Allentown. And this one is Neighborhood 1. And this one is Neighborhood 2. Okay? So we've broken it down this way to illustrate how many jumps it takes just to get from the internet down to your neighborhood. And Center City, Allentown can be broken down into dozens of different groups as well, but we're not going to do that. We're not going to go that far here today. Instead, we're going to say neighborhood 2. So when we break it down, we're going to draw a whole bunch of lines here that represents different houses. So house 1, house 2, house 3, house 4, drawing is not my strong suit, 5, and we're going to say house 6. I'll draw the box around the letters. There we go. Okay, so now we see that that house 1 through 6 in this neighborhood. Now we can imagine that this neighborhood might have, let's say, let's go up to house 100. Okay, it's a good sized neighborhood. Now, all of this bandwidth that comes from the internet, all the way down as we go from the internet to Penn Teledata to Allentown to Route 1 to Neighborhood 2 down to House 3. We can imagine if this is a very good neighborhood as far as internet access goes, they may have, like I have at my home, let's say a 500 megabit download connection. Now, remember, upload and download speeds are not the same, but we're just going to generalize and say 500. And let's say house 1 isn't going to pay quite as much, so they're only going to have 100. House 2 has the same 500. House 4 only pays for 250. And we have 100, 100, and so on. The whole neighborhood is only going to be capable in good cases of about 100 gigabytes. So we're talking about gigabits and the connections. I'll generalize it to make the math easy. We say 1 megabyte, 1,000 megabytes equals 1 gigabyte. Okay, so easy math. That's not the exact calculation, but we're going to run with it. So when we say we have 100 gigabytes here, and that would be a good neighborhood connection. Every house here shares that 100 gigabytes no matter what you pay for. You may pay for 500 megabytes, but what you're going to get instead is if I have 100 homes, right? So I have 100 homes, and let's say, no, let's do it a different way. I have 50 homes that get 100 megabytes. So that gives me 5,000 megabytes, which is 5 gigabytes. Not a big deal. But if you then take 500 and multiply it by the same 100, 1, 2, 3, 4, we go 5, we now have 50 gigabytes, right? So this neighborhood should be okay, assuming they have the best possible connection here. But many neighborhoods, and that includes places like Center City, Allentown, those regions are not going to have those 100 gigabyte connections. Instead, let's go out to neighborhood 1 and say it only has a 10 gigabyte connection, and it has the same 100 houses. Whoops. So we take the same 100 houses that have 50 gigabytes of throughput. It's not 500, that's for sure. The throughput through this 10 gigabytes. Well, how does that work, you're wondering? Well, the way the internet service provider, who is Penteledata, deals with that is they load balance the connection going through. So when they look at it and they say, well, house number 1 maybe is paying for the 500, while house number 2 is paying for 100, we can provide house number 2 with 80. House number 1's only going to get 200 because I gotta give internet speed to everyone else in the neighborhood. So what you get out of your 500 megabyte connection is really only 200. And what they do with this 10 gigabit connection up top here, right up here, is Penteledata tries to never maximize that connection. However, when you've sold 50 gigabytes of connectivity on a 10 gigabit connection, and I promise you it happens, you max that out, which means that these 100 houses are now fighting to get through that 10 gigabit connection, and these speeds, this 80, which can then become 60 or 50 or 12, or then jump back to 100, these connections now become unstable going out to the internet. So let's shift over and assume for a minute that you're going out to, excuse me, to Microsoft. Microsoft is going to have a tier 1 connection most of the time as far as their delivery. Now, Microsoft works through their own Azure Cloud. So if you're using Office 365 or Teams or N Teams, you're going to find that your Microsoft connection to that, your connection to them is going to be a tier 1 connection, and they're going to have, pretty good bandwidth. I don't know what they have. I couldn't pretend to know. However, Microsoft has their Azure Cloud, and what they have is that cloud connects to data centers all over the world. For our purposes today, we will just say, we'll just talk about ones in the United States. And these data centers we'll say there's one in North Carolina, we'll say there's one in Texas, and one in Colorado, very popular places for data centers. So if you are on the East Coast, Microsoft, so let's say you're coming from Quakertown, Microsoft is going to route your traffic from Quakertown through the internet, and once it gets to Microsoft, they're going to say, you're from Pennsylvania, you're going to go to North Carolina, because that's the fastest path to get to where you want to go. Once they've determined that, and we're going to pick this color here, we now get off into different server farms by which different services are provided from Microsoft. Boop. So this server farm, we're going to assume handles, let's say, PA and New Jersey. This one, New York and Massachusetts. This one, let's say, we'll call it the Northeast above New York and Massachusetts. And we'll call this one Virginia and Maryland, okay? How accurate is all that? I don't know, but that's pretty much how they would design those things. I'm going to now erase these very poor calculations that I did here because math isn't my thing. So now we have we have a data center in North Carolina and 4 different geographically divided server farms. So within Pennsylvania and New Jersey, it's going to break down into a further set of server and services. That will start here. And we'll call this server farm, because the PA New Jersey part is we're going to call this is the router that routes the traffic. And then this router, or it could be a server, says, okay, what are you trying to do? And it's going to handle your login, maybe, to Office, your access levels, those sorts of things. But you still haven't actually clicked on anything yet. Or maybe you have. It depends on where you've gone. Now, if you have gone, say, instead of going to office.com and logging in and then clicking on Microsoft Teams, you've just opened the Microsoft Teams client. This traffic is going to pass right through here and go right over here, because this one is what I'm going to call our Teams server. Whereas this one maybe is OneDrive. And maybe this one is Office applications such as Word Online, OneNote Online, Excel Online, that sort of thing. So we've broken it down a little bit. And as your traffic comes through and you've said, I want Microsoft Teams, this is going to authenticate you. This is going to say, okay, you can go to Teams. Here's your Teams server for Pennsylvania in that area. Now, that is the basic idea of how your traffic goes from wherever you are through the internet to the corporate network that you're trying to access. Now remember, these server farms, so let me move that in a little bit, these may have 50, 100 servers, 1,000 servers, who knows? That's the sort of information you won't get from any of these vendors. However, the data center is going to handle your traffic as best it can based on when it comes in and what you want to do. So when you think to yourself, why is Zoom slow today? Or why is Teams not uploading my video to stream right away? It's because all of this traffic has to go back and forth, and each one of these stops. So I look here, and we're going to put you back in, we'll go back to Quakertown. And we will say, this is your regional router, and this is your house. So each step along this uplink, oh, that's the wrong color. So we have here, we have rules. Our bandwidth is throttled here. So we have bandwidth. Here, as we come up to here, we have rules. Bandwidth throttled again. We come to here. PenTeleData has rules. And you're less likely to see the throttling as much at this level because PenTeleData has a much larger capacity than these different regional ones will have. And then you're going to come all the way over here. And then Microsoft has its own rules and it routes your traffic. All of that takes time. Once it gets once it's routed it to North Carolina, their rules apply. This router here has to think about what you want to do and then route it appropriately down to here. And each time you go this way or this way, all of these things happen. So when we think about how the internet moves the things that we need it to move, we have to keep all of this in mind and remember that the internet isn't magic. The internet is a very well-designed system that handles all of these different things based on different rules. However, they're all different rules from different places and they all apply in different ways. I hope this was helpful. Have a great day.